Hello everyone, let's do trig sub today. This is a typical trig sub problem because you can see this expression that's inside the square root. If we plug in the trig function into this x here and then apply the Pythagorean identity, then we can turn this expression into a perfect square. And that will cancel out with the square root here, and so that we can integrate this function directly. Okay. Usual u substitution will not work because if we let u be the stuff that's inside the square root, and when you find the du, there is no way that we can get rid of the other x squared. Maybe we can, but it may still give us an expression that's hard to integrate. And so that's why we say that, okay, we are going to do the trig sub on this integral here. Okay, so let's get started. First, as you recognize the form, we have the 4 minus x squared right here. That looks like the sine square plus the cosine square equals 1 because we have, if we isolate the cosine square, then we are going to get the 1 minus the sine square, which looks like in this form. So the way that we do it is that we are going to start by making our trig substitution. We are going to let this x be 2 times sine theta. Okay, so 2 times sine theta in this case. And then you may say, how do we know that's the 2? The way that we decide that that's a 2 in front of the sine theta is because of this, the square root of this number. So if this is 9, then we are going to put a 3 in front of the sine theta here. Okay, so now when we differentiate this equation, then we are going to get dx over d theta. Okay, but I'm going to put the theta on the right hand side of the equation. So when we differentiate the 2 sine theta, we are going to get 2 cosine theta and then d theta. Okay. And then so once we get this, then we can start substituting all this into the integral and see what's going on. Okay, so the way that we do it is that we are going to have the integral, right? And then we have the square root, the 4 minus some stuff squared. And what is that stuff? That stuff would just be this expression right here. We have the 2 sine theta. And then actually, I may just change the color for this dx right here so that it's easier for us to distinguish the stuff. Okay, so now the denominator, we also need to substitute that x into the denominator, which will give us the quantity of 2 sine theta square in there. But one thing that's really important is that we do not forget this dx right here. So make sure that we also replace the dx by this 2 times cosine theta and then d theta, right? So we have the 2, then cosine theta, d theta here. So now that looks messy, but when we simplify, things will get better. So in general, we are going to deal with the stuff that's inside the square root first. So we are going to get the square root, right? And then we have the 4. And then now see what's going on here. We are squaring the 2. So we are going to get 4 minus 4. And then we square the sine theta, right? So we are going to get sine square theta. Okay, so that's our expression that's inside the square root. And then what about the expression at the bottom? The expression at the bottom would be squaring the 2. So squaring this 2. So we're going to get 4. And then squaring the sine, we are going to get sine square theta as well. And then as you can see here, there is still this dx that we need to put in the numerator, right? So we are going to just copy that. And then we're going to put the d theta at the end. Okay. It's up to you. You can also put the d theta on the numerator. So now we can factor the 4 from we factor the 4 from both terms here, and then it turns into the integral of the 4, and then we have 1 minus sine squared theta. Okay. And then we also need to worry about the denominator. So we have the 4 sine squared theta here, and then so the 2 cosine theta d theta. So see that we can actually take this 4 outside the square root, which will become a 2. And then it turns out that the 1 minus cosine square that will turn into a cosine square, right? So let's continue with the calculation. So we have the integral of the 2, and then the square root of just the cosine square theta here, and then times. And then we also have that 2, and then cosine theta d theta here. And then in the denominator, we are going to get what? We are going to get all that same stuff down there. So we are not changing it yet, right? So it's 4 sine square theta. So now we can start simplifying the integral. So when we simplify, we can see that we can cancel the 2, and then this 2 with a 4. So all those numbers are gone. And then all we need to do now is to worry about the square root of cosine squared theta. And then when we remove that, let's just think about this. This square root of cosine squared theta actually is what is absolute value of cosine theta here. And then now when we define this x equals 2 sine theta, we are actually also defining the sine inverse at the same time. So when we look at this expression right here, we actually are talking about sine theta, right? If we solve for sine theta here, then we are going to get x over 2. And then if you just continue to solve for theta, then you get theta is equal to sine inverse of x over 2. So in order for this inverse function to be to exist, then we actually require that the angle, the domain of this function to be in quadrant 1 and 4, because the domain for this function would be from negative pi over 2 less than or equal to theta less than or equal to pi over 2. Okay, so what happens right here with the absolute value of the cosine is that in both quadrant 1 and quadrant 4, cosine is going to be positive, right? It's going to be non-negative. Cosine can be 0 at, actually cosine can only be 0 at the pi over 2 and then the negative pi over 2. So in this case, we don't really need the absolute value. So because of that, we can say that cosine absolute value of cosine theta would just be cosine theta here. So that means in the next step, we are going to get the integral. Now, this turns into cosine theta, right? So we have the cosine theta here. And then what about the other one? The other one is the green cosine theta, so that's there. Okay, and then with the d theta. And then you are going to get the denominator, which is still just the original one, right? The sine square theta. Now, putting the cosine together, right? Putting the cosine together will just be cosine squared theta over sine squared theta, d theta. Now turning that into a function, into a single trig function, that would actually just be what? That's actually just cotangent squared theta d theta. Just know that we cannot really integrate this directly, right? So we can use the trig identity to turn it so that it will be the integral of cosecant squared theta minus 1. And then this time we can integrate. So when we integrate, we are going to get we don't need the integral symbol anymore once we get the antiderivative. So the antiderivative of the cosecant squared theta would be negative cotangent theta. And then what about this minus 1 here? The antiderivative of it would be minus x. I mean minus theta in this case because our variable of integration is theta. So the problem is basically done, but then we're in a different variable than x. So we need to switch this back into the variable x. So how do we do that? At this point, we need to draw a triangle that's based on this sine theta equals x over 2. And then we try to come up with an expression from the triangle for cotangent theta. This theta right here would be easy because we already found it. It's going to be theta equals sine inverse of x over 2. So that one, we don't need to worry about it. So all we need to do right now is to draw a triangle based on this sine theta equals x over 2. Okay, so let's do that. So first we can just draw a generic triangle here, a right triangle. And then so we have, look at the theta right here. So let me just shade this angle just for us to see more easily. Okay. Now for the theta, right? Then what's going on here? Sine of this angle theta is equal to x over 2. So where do we have the x? X is the opposite, right? So we will label the x right here. And then what about the hypotenuse? The hypotenuse would be 2. So the adjacent would be, you can actually figure it out by applying the Pythagorean theorem, right? So we have 4 minus x squared. Okay, so we get that. So now continuing with our problem, then our answer, right, would be what? For the negative sign here, we just copy that negative sign. And then we have the cotangent. Cotangent would be adjacent over the opposite. So we are going to get square root of 4 minus x squared. And then over the opposite, which is just x. Okay. And then the other one is a minus, what is that? The theta is equal to sine inverse, right? The arcsine function. So that's equal to the arcsine function of x over 2 in this case, right? And then, so that's that. And then we also add the constant of integration. So we're finished with this problem. Okay, so that's a long process, but I'm showing a lot more details than necessary sometimes. As you can see, I show the plugging in, I show the simplifying, and when you become better, you actually can skip some of the steps, which will make the process less tedious in this case. Okay, so if you like this video, please subscribe to my channel and then give me some support. Thank you for watching this video, and I will see you next time.